Good morning, ladies and gentlemen. I would like to introduce myself. My name is Bambang Agus Purwono. I am a lecturer in State Polyechnic of Malang, Indonesia. First, I would like to thanks to the President of APC Mahalaxmi College for Women in Thoothukudi, Tamil Nadu, India. And the second, the organizing committee and the conference chair, also Dr. Susan. I would like to present my research paper. The title is How to Optimize Green Open Space Using Hydroponics Closed Cycle System. This paper will be presented in international conference on recent trends in multidisciplinary research, ICRTMDR 2021, organized by the Internal Quality Assurance Cell, APC Mahalaxmi College for Women, Thoothukudi, Tamil Nadu, India, on 8th and 9th of April 2021. The outline is research background, literature study, and research method, result and discussion, conclusion, and references. The introduction, the research background. Number one, all people needs of green open space. Number two, according to Indonesian Planning Spatial Law, number 27 on 2007, the green open space is not less than 30%. Number three, the public open space, national public open space is less than 20%. And the total of private open space is less than 10%. The ratio between of green open space and the total land use is decreasing. The problems, now you know the area of the living home is relatively narrow. Number two, also the private area also narrow. Number three, the area of the outdoor living homes, the open space is also narrow. Number four, the green open space is narrow in our residence. Number five, the price of 9 kinds of basic needs, the price of the rice, the meat, vegetable is increasing. The research objective is, there are two research objectives. Number one, to design and to make the hydroponic equipment as a pilot project. Number two, to analyze the effect of the aid toward of the aid of kangkung plant. The limitation, we designed the hydroponics equipment. There are PVC pipe. The diameter is 2.5 inches, 3 inches, and 4 inches. Number two, the distance between the holes between the net pot is 15 centimeter, 20 centimeter, and 25 centimeter. The type of seed is Chinese kangkung super seed. The research variable, number one, the water circulated or transported using centrifugal pump powered by solar cell and closed cycle system. Number two, the fertilizer circulated or transported using DC centrifugal pump powered by solar cell. Number three, cultivate the catfish and raise the kangkung plant. The literature study. Hydroponics. Hydroponics is Greek language. Hydros means water and ponos means power. So the hydroponics is the process of the growing plants in sand, gravel, or liquid with added nutrients but without soil. The definition of hydroponic is the growing of the plant in nutrients solution with or without an inert medium such as soil to provide mechanical support. Number two, the alternative of soil media is neutral media. For example, rock wool, cocoa peat, perlite, vermiculite, sand, and the solvent of fertilizer. The hydroponic system, there are two hydroponic systems. Number one is weak system, representative of the static solvent, and number two is nutrient film techniques system, representative of the dynamic solvent. This is the figure of the weak system. This is the schematic of the NFT system. There is the water pumps by centrifugal pump and then enter to the PVC pipe in hydroponics equipment and then circulate for some hours. The reset variable, there are three reset variables. Number one is the age of the kangkung plants in days. Number two, the diameter of hydraulic PVC pipe in inchi. And number three, the height of the kangkung plant. This is the dependent variable. The reset approach is quantitative methods using one-way ANOVA or one-way classification. The hypothesis, the null hypothesis is there is no effect between the kangkung age and the kangkung plant height. The alternative hypothesis, there is an effect between the kangkung age and the kangkung plant height. The mathematical model using design experimental YIG is mu plus AKP E and epsilon IG. AKP is the age of the kangkung plant days and Y, the dependent variable, is the height of the kangkung plant in millimeter. This is the flowchart diagrams, reset flowchart. We start in this and then preparation. We need the field study and literature study, and after that we identify the problems and we design the hypothesis, and we start with research methods using quantitative approach, and then we start with experimentation. It is okay. We collect the data and start to computation, and then we document the conclusion. This is the closed cycle system. This is the hydroponic equipment and the kangkung plant. The water circulate or transported using centrifugal pump DC powered by the solar cell, and then the water, including the fertilizer, goes into the inside the pipe of the hydroponics. And then the water in the pipe of the hydroponics transport to the catfish pond. There is the fertilizers. This is many of the water, and then water circulate by pump that's continuously. This is the solar cell. The power is 350 watt peaks. This is the 3D drawings, the catfish pond. This is the PVC pipes. Then this after a few weeks, we remove from the settling to hydroponic equipment, and this is the catfish pond. There are hundreds small catfish. This is the solar cell installation, 350 watt peaks. This is the seed of the kangkung plant. To raise the seedling kangkung plant for 5 days until 1 week. After that, we remove the net pot to the hydroponics equipment. And after a few weeks, we measure the height of the kangkung plant, and this is the distance between the net pot. We have 15. The distance between two holes. We have 15 centimeter and 20 centimeter, and the other one is 25 centimeter. And the diameter of PVC pipe is 2.5 inches and 3 inches and 4 inches. This is the cultivate of the catfish. This is the centrifugal pump for circulating the water. We can, after 23 days, we can harvest, cut the branch, and we rest 3 branches of the kangkung plants, and then the next of this 3 weeks we can harvest another. We can harvest it until more than 5 times. This is the data of the height of the kangkung plants and the duration of the age of the kangkung plant, and then we have 6 treatment, and we measure using the 1W ANOVA, and we decided that or the conclusion of the 1W ANOVA, or the result of the calculation is the sum square between treatment is 7,611.6, and the degrees of freedom of the treatment is 5. The mean of the sum square between treatment is 7,611.6 divided by 5 is 1,522.3, and the sum square error is 21,516.4, and the degrees of freedom is 54, and the mean of the sum square is sum square error divided by of degrees of freedom is 398.9. 8.45. The sum square total is 29,128, and the degrees of freedom is 59. 60 minus 1 is 59. And the F ratio is mean square between treatment divided by mean square of the error is 3.82. And we compare between the F ratio using F distribution. The F table is 2.39. So the null hypothesis is rejected. This is the graphic of the data. So we can see the result of the computation. The conclusion, the F ratio is higher than F table. 3.82 is higher than 2.39. It means the null hypothesis is rejected. It means there is an effect between the age of the kangkung plant and the height of the kangkung plant. The subjective conclusion is the fiber of the kangkung plant is mild, and the taste of the kangkung plant so sweet enough, I think. Then every 3 weeks we can harvest the next kangkung plant. This is the references, and this is the biodata, and thank you for your attention.